guys, so I know I haven't made a video in a long time, and I think I went over like for loops and stuff really fast. So I think it's better that I make a video on a for loop. So I'm gonna take a very simple video. I'm gonna call it um series sum. That's what I'll call my class, series sum. So I'm just gonna remove all that. Let me make the font bigger so that you can see. I was getting some complaints that the font was too small. I think this should be big enough for everyone to see, and I'll make it even bigger, I guess. Let me make it 20. Yeah, I think this is good. So I'm gonna call it class series sum, and basically the objective of this program is to find the sum of all the numbers from 1 to 100. It could be very well tedious to do it from 1 plus 2 plus 3 all the way up till 100, and there is a way in math to do it called arithmetic progression. I don't want to get into that right now, but I'll show you how to do it through a program. Let's say we create a class called series sum, have a main function, and we need to store the sum in a variable, so we let that equal to 0. In sum equals 0, type for int I equals 1, I less than equal to 100, I plus plus. Now what we do is we write sum plus equals I, close the brace, system dot out println sum. Now let me go over this code. I think you all are familiar with the class and function declarations, and we're just initializing a variable called sum, setting it equal to 0 initially. Now what happens when you write over a variable? Let's say I have a variable called x. X is initially equal to 4, then I write x equals 5, so that 4 gets erased and the new value of x becomes 5. So if I write sum plus equal to I, it's the same as writing sum is equal to sum plus I. This, the first, these things are the same. So what you mean is, in this is new value of sum equals old value of sum plus value of I. That's what you mean by this statement. It can also be written like that, sum is equal to sum plus I, and what I just showed you, sum plus equal to I, it's a shortcut operator, makes your work easier. So yeah, I got class compiled with no syntax errors. Let me try running this. New series sum, void main, and we get the answer as 50-50. Now if any of you want to verify that, let me take out my calculator. Um well, 1 plus 2 plus 3, I don't want to do that, so if you guys want to verify that, then well, go ahead. So yeah, that's the first program I'm showing you. Let me get on the second one. It's called It's called, let me see, let me think. I'm gonna give you something a bit challenging this time. What you have to do is you have to check whether a number is prime or not. Prime. That's what I'll call my class, class prime. Now, how to go about this? Now I've taught you parameter input, so you just take input of n, which means number. Let me make that int num. So yeah, you've got your number. Now you need to check whether it's prime or not. Now, what is a prime number? I want to make this definition very clear to all of you. A prime number is one that can only be divided by 1 or itself. So what they're basically saying is, if you take a number, let's say 11, it can only be divided by 1 and 11. It cannot be divided by any other number. So let's keep a number, or rather let's keep a variable called int factors and set it equal to 0 initially. So what we know about factors is, well, a factor of a number is a divisor. In simple terms, basically, if it can divide the number leaving no remainder, that's called a factor. So and in this video I'm going to introduce a new command called the modulus operator. It's very interesting. So let's start a loop from int I equals 1 to I less than equal to the number, and then you write I plus plus. So what are we doing here? We're starting a loop from 1 to the number. So if you take a number 11, it'll go from 1 all the way up to 11. So now what you write is, if num percent I. Now this percent is the modulus operator. What it basically does is it gives you the remainder of anything. So if num percent I, basically what it returns is, it gives you a value which is the remainder of num divided by I. So let's say you have 11 and I is 1, so I 11 divided by 1, it will give you a value of 0. 11 divided by 2, it will give you a value of 1. That's the remainder, because 2 goes into 11 5 times and leaves 1 remainder. So if n mod I equal to 0, factors plus equal to 2. Wait, sorry. Factors plus plus. My mistake, I'm really sorry. And I forgot to give the brace here. And if the factors equal to 2, sorry again. Yeah, then you print system.out.println num is prime, else system.out.println num is not prime, and you close your class and function there. So let me go over this code. Really simple. You take your number as input, you store a variable called factors which is equal to 0. Now a prime number, if you take a prime number, let's say 101, 101 has only two factors, 1 and 101. That's why it's a prime number. Now, so you start a loop from 1 to the number equal to the number, so that both the number and 1 are included. And well, if it's equal to 2, which means if 1 and number are the only factors, then well, you print its prime. Now let me explain modulus to you. Basically, if you have two numbers 5 and 2, 5 more 2 will be 1, because 2 goes into 5 two times and leaves 1 as remainder. So modulus just finds the remainder. I'll make a separate video on modulus explaining how it works and what it is exactly. But just know that it gives you the remainder when one number is divided by another. So let's compile this and try running it. Let me think of a prime number. 103. 103 is prime. See, it prints it there. Let's think of another prime number. Simple one. 7. Print 7 is prime. Let's say 101. Now let's try something that's not prime. 102. 102 is not prime. So you can see it's really working. And I don't know, in some books you may see that this same code is written in a slightly different way. It goes from 2 to less than the number, and well, and here it will change to 0. Now if you haven't figured this out by now, let me explain to you. Basically, when we went from 1 to the number of factors we got was 2. So if you go from 2 to less than the number, basically you're not including the number. That means the number of factors you'll get is 0, because if it's a prime number, the only factors are 1 and the number. You're excluding the chances of 1. You're starting from 2, so 1 can't be. You can't check for 1 because I will never be 1. And well, you can't check for the number because I is less than the number. So you won't get any factors. Now, why I don't like, or rather why I didn't show you this method in the beginning, is very simple. Let's say I enter 1, whether I want to check whether 1's a prime number or not. It prints 1 is prime. Now, I don't know if many of you know or not, but even I'm not sure about this, but I don't know whether 1 is prime or not. I think it is, but if you look at the program technically, if you input 1 here and you start a loop from 2 to less than 1, that makes no logical sense. Which is why going from 1 to less than equal to the number, you can go from 1 to 1. It makes perfect sense. And that's why I preferred the first method I showed you, but whatever you guys are comfortable with, you can use that method. So I hope this video helped you guys, and I'll make another one soon. So peace.